Hello guys, this is Mr. Ala, your math teacher. I hope you're doing well. In this video, I will try to correct the most important exercises you did in your book concerning the chapter on the equations of straight lines. And we will explain the last idea in this chapter, which is the equations of vertical and horizontal lines. Let me start with a quick reminder on the types of equations of straight lines. As we said before, there are two types of equations. The first one is slope-intercept form, and the other is point-slope form. The first one consists of this form: y equals mx plus b, where m, or this number, remember the number multiplying x, is our slope, and b is the y-intercept. The second form, the point-slope form, consists of a point and a slope. The point is this point, the point having these two as coordinate, and m is the slope. And now focus on the form of this particular form of an equation of a straight line. It comes as y minus something, as I said in the previous video, and x minus something. Okay, we will talk about this idea later, but you need to understand from the beginning that this form comes as y minus something and x minus something. Okay, the first exercise I want to talk about is exercise 16, page 194. In this exercise, you will see the first form of an equation of a straight line, which is the slope-intercept form. It's y equal x plus 2, yani it's in the form of y equal mx plus b, because it's y isolated on the left and it's equal to something times x plus another number. Okay, so the number multiplying x, as I said before, is the slope. In this case, m is equal to 1, and the other number, which is the y-intercept, in this case it's equal to 2. Now, as you remember, we said that you always start with the y-intercept to draw the line. So again, as a reminder, this number 2 will refer to the steps on the y-axis, either upwards or downwards. Now in this case, it's positive 2, so you're going 2 steps upwards. If it was negative, you're going 2 steps downwards. So all I know is I'm going 2 steps upwards. So I'm reaching this point right here. Okay, now let's look at the slope. The slope is equal to 1. M is equal to 1. And as I said before, you always look at the slope as a fraction. And since it does not have a denominator, you're going to put 1. So the slope is equal to 1 over 1. And the numerator in the slope refers to the number of the steps on the y-axis, as it is the case with the y-intercept. And the denominator refers to the numbers of steps to the right. Always steps to the right. Okay, so I'm going 1 step upwards and then 1 step to the right, starting of course from the point I plotted before, which is this one. So I'm going 1 step upwards and then 1 step to the right to reach this point right here. If you connect them, what do you get? This line. Okay. Another example I wanted to talk about is exercise 18, page 194 also. So the same thing, it's in the form of y equal mx plus b, as it's y equal something times x minus 1, right? In this case, our slope, the number multiplying x, is equal to half, 1/2, and the y-intercept is -1, right? So what do we start with again? The y-intercept, of course, right? And as I said a moment ago, the y-intercept refers to the number of steps on the y-axis. Either you're going up or down, and in this case it's negative, it's not positive. In the previous one it was positive, so we went upwards. In this case it's negative, so I'm going downwards. So I'm counting one step downwards and I'm stopping here on this point. Okay? Then I look at the slope. M is equal to 1/2. And as I said, you always look at the slope as a fraction. And in this case, it's already a fraction, so it's easier for us. 1 refers to the number of steps on the y-axis. In this case, I'm going upwards because it's positive. And 2 always refers to the number of steps to the right. Okay? So I'm going 1 step upwards and 2 steps to the right, so I'm reaching this point right here. And when I connect these two, I get the drawing or the graph of this line. Moving on to the second form of equations of straight line. Exercise 20 is an example on the second form of equations of straight line. Look at this equation, y minus 3 equals 1/3 into x minus 3. And again, when I talk about the equation in the form of the point slope form, I'm thinking about this equation right here. As I said, y minus something equals m into x minus something. So this is the way you will be looking at things. Y minus something and x minus something. Okay? And these two numbers that we're talking about will form a point for us. Okay? A point to start with. In this case, it's y minus 3 and x minus 3. So my point is 3, 3, because it's y minus 3, x minus 3. Okay? So this 3 goes here, and this one goes here. Okay? The other thing we will be looking at is the slope, which is in this case 1/3. Okay, and again, as it is already a fraction, so we're gonna take the numerator, which is 1, as the number of steps upwards because it's positive, and the denominator as the number of steps to the right. So starting from this point, 3, 3, here it is, 3, 3, that's our point. I'm going to count 1 step upwards and 3 steps to the right, 1, 2, 3. So you're going to reach this point, and if you connect these two, you will get the graph of this line. Another example on the second form of equations of straight line, the point slope form. Now, as I said, I'm going to be thinking of the equation as this one, y minus something and x minus something, right? Y minus a number and x minus a number. In this case, as you see, it's y plus 1, not y minus, and x plus 4, not x minus, right? So what I have to do is show the minus that I need in the equation to find the point. Remember that these two numbers will make a point for me, right? A point to start with. So to find these 2 points, or these 2 coordinates, we have to show the hidden minus. In this case, it's y plus 1, and it is supposed to be minus. So what I'm going to do is show the minus. Can I write it like this? Y minus minus 1. Isn't it correct? Y minus minus 1. Of course it's correct because minus times minus makes plus. So I did not change anything, right? But what I did is I showed the minus. And for x, it's x plus 4. So we're going to do x minus 4. So my point is minus 4 minus 1, right? So here I am counting 4 steps to the left, 1, 2, 3, 4, and then 1 step downwards because the point is minus 4 minus 1. So minus 4 minus 1, I'm reaching this point, and then using the slope, which is in this case minus 2 over 3, I'm counting how many steps to the left or to the right. Can you answer that? It's 2 steps to the left. It's 2 steps downwards. First we look at the numerator. So we're going 2 steps downwards because it's minus 2 over 3. So minus 2 will make 2 steps downwards. And then we're taking 3 steps to the right. So starting from this point, we're going 2 steps downwards. 1, 2, here it is. And then 3 steps to the right, 1, 2, 3. So we're reaching this point. And when you connect these 2 points, you get the graph of this line. The last exercise I wanted to talk about is exercise 28. As all the exercises are similar to each other, so this is what I did. I picked some of the exercises or the most important ones of them. In exercise 28, you are supposed to find the slope of the straight line having the graph of the straight line. Okay, so to find the slope, there is a rule. We showed this rule in the previous video. We said that the slope m is equal to y minus y over x minus x. So all you have to do is find 2 points A, B on this straight line, knowing their coordinates. And what you're going to do is y of the first point minus y of the second over x minus x. That's it. As simple as that. Here you have 2 points, B and A. B has 3, 5, and A has minus 5, 3. So we're doing YB minus YA, which is 5 minus 3, and XB minus XA, which is 3 minus 5. The answer would be 1 over 4, so the slope is 1 over 4. Okay? And if you don't have the graph, he gave you 2 points, like in exercises 30 and 31, 32, he gave you 2 points on the line. So what you have to do is call the first one A, the second one B, and then apply this rule. Okay, guys? Now, before we move on to the last part of this chapter, I wanted to talk about this exercise, 44, page 195, and it's a pretty simple exercise. He said in the book, write each equation in the slope-intercept form. So you're going back to this form, y equal mx plus b. And basically what you want to do is to find this form, or to turn this equation into this form, you're going to isolate y. You want y to be alone next to the equal. You want y equal. Okay? So this is our objective. The main objective is to turn the equation in the form of y equal. Here you have y minus 5 equals 2 into x plus 2. As you see, it's in the point slope form. To turn it, as I said, I want y equal. So the first step is moving this 5 to the other side, and by moving it, we change its sign, right? As we did in the equations. Now, y minus 5 becomes y equal this, we did not change it, plus 5. Now, we don't leave it like this. Remember, we need this form, y equal mx plus b. something times x plus another number. So we're going to multiply 2 by x and 2. Okay? So if you want to, we are expanding. Now it's 2x plus 4 plus 5. So the final form is y equal to x plus 9, which is in the form of the slope-intercept form. Okay? Finally, we're going to talk about the equations of horizontal lines and vertical ones. Now, as you see, I wrote y equal a and x equal b. Now, in this case, b is not the y-intercept, or a is not like a number that you should know. No, I mean that the general form of a horizontal line or a vertical line is y equals something, let's say 2, and x equals, let's say, minus 1. So this is the idea. A horizontal line is a line that comes in this form, y equals a number, any number. We are going to teach you how to find this number in a moment, but this is the idea. If it's horizontal, its equation is in the form of y equals any number. If it's vertical, it comes as x equal a number. Okay, so in this case, there isn't a relation between x and y. There isn't an equation that has x and y at the same time, at least. Okay, so it's not y equal mx plus b. It's not the second form of the equations. No, it's y equal or x equal. Okay, so where did we know these forms of horizontal or vertical lines? Okay, so here are two examples of vertical and horizontal lines. The line in green, this one, is a horizontal line, right? So what is so special about this horizontal line? As you see, if you pick, let's say, 3 points on this line, let's say this one, and this one, what do they have in common? Like this point, and this point. Of course, their axes are different, right? This one, let's say this one is minus 3, this one is 0, let's say this one is 3. Their axes are different. But what about their ordinates? What about the y of this line or of this point? What is the ordinate of this one? It's 2, right? What is the ordinate of this point? It's 2. So this is what's so special about this line. Every point or any point on this line has the ordinate 2. So this is why we call it y equal 2. Okay, this is the equation of this horizontal line, y equals 2, simply because all the points on this line has 2 as y. Their ordinate is equal to 2. Now, talking about this line in red, the vertical one. Now, the horizontal one had something special, that all the points had the same ordinates, right? Type, can you find something also special in this vertical line? This one. Take this point, and this point. What do they have in common? Like in this case, their ordinate aren't the same. This point has minus 3 as ordinate. This point has, let's say, 0 as ordinate. This point has 3 as ordinate. So y is not the same in all the points. But what about x? Well, what is the x of this point? What is the abscissa of this point? In this case, it's minus 4, right? But what about this one? This point also has minus 4 as abscissa. So all the points on this line has something special or something in common, which is x. That's equal to minus 4. So this is why the equation of this straight line or this vertical line is x equal minus 4.